Hi friends, in this video we'll go over the basic concepts of Java. We will go over the Java architecture, basic terms like JDK, JRE, JVM, and the Java strategy of build once and run anywhere. If you're a seasoned professional and you just want to brush up on what are the basic concepts in the JDK, JRE, and what are the components being used for Java memory management and so on, then this is a good video to start on. So let's get started. What is Java? Java is a high level programming language which is using object oriented programming model. When we say high level, Java does not expect developers to deal with machine level codes. Computer understands machine level codes. As a developer, what Java developer does is write instructions based on the Java programming instruction set. So you write a particular program using the keywords and the data types and so on, and those are internally converted into a machine language equivalent code by the compiler. So as a developer, you write your Java code in files with .java extensions. Those .java files are fed to a compiler which generates a bytecode representation in a .class file. So your compilation takes .java files as an input and generates .class files as output, and this particular .class files are then fed into a runtime environment, Java runtime environment. The Java runtime environment will basically load those particular .class files, it will verify the code and it will execute the code, allowing that code to also interact with other operating system capabilities like files and so on, using the runtime ecosystem which is available with the Java runtime environment. So let's go over the key terms of JDK. JDK stands for Java Development Kit. It's a complete package of compiler, Java runtime environment, as well as other tools which are handy to monitor or profile a corresponding Java runtime ecosystem. JRE stands for Java Runtime Environment. It is basically an implementation of JVM. JVM is more of a runtime environment to execute Java programs. It's more of a spec, and JRE is the implementation. So JVM basically loads your .class files. It will verify, execute the code, and so on. What makes Java special is it has certain outstanding characteristics like automatic garbage collection. So the moment the objects are used and are no longer required, those are garbage collected. It has its own implicit memory management, so you don't have to go and define that, so and that the integer requires, let's say, 8 bytes of memory and so on. So that is implicitly managed by Java. Concurrency management, so if you are dealing with multiple threads, the concurrency management is already supported internally via JVM, providing developers a very robust abstract API to work on. And security manager allows you to define security policies, how you could run your code, whether the code is signed or not, what permissions are required, and so on. Let's move on to the JDK tools. We have JMC. It's a tool suite for monitoring and profiling a runtime application. It consists of JMX console. JMX stands for Java Management Extension. Okay, and then we have the Java Flight Recorder. JConsole, it's a graphical tool allowing you to monitor and manage the behavior. JMap allows you to get an insight on how the memory is leveraged by your Java application. More insights are available in terms of heap memory dump and the object memory maps which are generated via JMap. JVisual VM, it's a tool, it's a very handy tool which allows you to combine lot of offerings via independent tools into a single platform. You could very well import a heap dump, a thread dump, and try to analyze get a lot of insight on what was going on in the runtime ecosystem at that point in time when you generated the dumps. Okay, you could also connect to a running ecosystem and try to get an insight on what are the kind of you know uh, what are kind of transactions going on, what is the memory usage, objects created, and so on. So a lot of things are supported as part of the overall JDK tools. Java H is the tool which allows you to generate C specific files, header and source files. So where does C comes from? Java has support for running native code, native codes which are running outside of the JVM boundaries. Okay, so let's say you have a C program, you want to interact with a C program running on an operating system. Okay, you could even plug and interact with such a program using JNI, Java Native Interface. Okay, Java P allows you to disassemble one or more class files. It basically allows you to get to what is the Java code looking like for a particular class file, what kind of source code was generated, or what was the optimized code generated for that particular Java file. Policy tool allows you to define policies in terms of what is the kind of permissions required and so on. Okay, so we'll go over the Java security architecture in a short while. Let's look at the components in the Java ecosystem. We have the class loader subsystem. So for JVM, as we saw, right, JVM is expected to load the dot class file. So that is the loading part of it. The dot class files are OS independent representation. So the OS independent representation allows us to build once and run anywhere. So the build once and run anywhere strategy is supported by a dot class file strategy. So the dot class files provides a OS independent way of looking at the source code or the program files. Linking allows you to link the corresponding dot class file to a OS specific programming, you could say machine code representation. Initialization is basically initializing any of the static blocks or variables as even before you try to run the objects or create the objects or run in the corresponding program. For in terms of memory management, we have method area, we have stack where all of your static data members, other things will go into stack. We have native area allowing you to interact with native code. We have heap where all the objects are managed. Other components are JIT compiler. JIT compiler is basically a just-in-time compiler allowing JVM to generate the best possible execution plan for a particular piece of code. So if you have a certain kind of dynamic data sets in your particular program and you expect JVM to use those, then JIT comes in handy to generate a corresponding instruction set or execution plan, we could say, for such kind of instructions. Garbage collector allows the JVM to collect any of the objects which are no longer required. JNI native libraries, as I said, JNI allows you to interact with native code, and security manager allows you to define the policies, permissions, and so on. So let's take a look at the Java SE security architecture. At a very high level, what is it containing of is it consists of various security policies which are applied to a particular source code. So a source code can be an archive, a jar archive generated which is signed, okay, or it can be an unsigned code representation. Those dot class files are loaded via class loaders, the security policies are applied, and then the code is fed to JVM to run into a sandbox environment. You will come across this word sandbox quite frequently. Sandbox implies that the ecosystem in which your code is executing, it is completely isolated from other processes. Okay, only the need only based on need of your particular program you might interact with native code and so on. Okay, so basically code runs with different permissions and there is no built-in notion of trusted code. And then we have resources interactions like files and printers and so on, that is also supported by the Java SE based on any policies that you set up. So that's a very brief overview of Java for a beginner. I hope this will help you get a very brief understanding of what are the various components. This video is a part of the Java 17 series that I'm compiling to help you get started. If you like my effort, please do share, like, and subscribe. Thank you.